Hi, now we are discussing on spinels and inverse spinels, which are very important in the point of CSIR and GATE exams. Okay, right. So now just look at this. So it is a general formula given for spinels. So that is A, B2 and X4. Okay. So in this formula, A indicates divalent cation. Okay. So A indicates divalent cation, and some of the examples for divalent cations are magnesium, chromium, manganese, iron, cobalt, nickel, copper, zinc, tin, etc. Okay, right. And in the formula, spinel formula, B indicates trivalent cation. Okay, so some of the examples for trivalent cations are aluminum, gallium, indium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, etc. Okay, right. And X indicates ligands like oxygen, sulfur, selenium, etc. Okay, right. So if you observe here, some of the elements are in a divalent divalent groups, that is in A, like iron, cobalt, nickel, and they are also present in trivalent cations. We are representing in trivalent B. So iron. So that's why here iron, cobalt, nickel. So that's why here is a chance of presence of different kinds of spinels. That means, so we have two types of spinels. One is normal spinel and another one is inverse spinel. Okay. So here look at normal spinel. So normal spinels are given by the formula AB2O4. Okay. So in this A, that means divalent cation, it occupies the tetrahedral void. Okay, so divalent, once again, divalent cation in the normal spinel, total divalent cations occupies the tetrahedral void. Okay, right, in the spinel structure geometry. Okay, and if you observe trivalent ions, so trivalent ions occupy the total trivalent occupy, so that is octahedral void in the spinel. Okay, so if this arrangement, this kind of arrangement, if we observe in a given spinel, so that spinel is simply called as normal spinel. Okay, so here I'm giving you one example, that is magnesium Al2O4. Okay, so this spinel is called as normal spinel because in this magnesium plus 2, okay, and it occupies tetrahedral void. Okay, and aluminum has plus 3, and this plus 3 ions, that means aluminum plus 3 ions occupy completely total Al plus 3 ions occupy octahedral void. So that's why magnesium Al2O4 it considered as normal spinel. Okay, right. And next, inverse spinel. Look at here. Inverse spinel has the general formula like this. So we have a B and in the bracket AB and O4. So this is the general formula for inverse spinel. Okay, so here B means, already we know that B indicates trivalent ion. So in the inverse spinel, half of the trivalent ions occupy tetrahedral voids. Okay, so once again, in the inverse spinel, half of the trivalent ions occupy tetrahedral voids. Okay, and half of the trivalent ions occupy octahedral voids. And here, so total number of bivalent ions occupy octahedral voids in the inverse spinel. Okay, so if we observe this kind of arrangement in the given spinel, so then we can call it as inverse spinel. Okay, so I have given some of the examples for inverse spinels are Fe3O4 and COFe2O4. So these are considered as inverse spinel. Okay, so and in the continuity of this lecture, so we are going to work on more examples and easy methods. Okay, to determine normal spinels and inverse spinels.